Examples 8 and 9 involve you describing aspects of this graph right here of a function. It's a function that's defined with a domain of -25 to 17, not including the -25, and going from -20 all the way up to 133. Now, as you describe these intervals, basically you're asking when the function is positive or greater than 0, less than 0, increasing, decreasing, concave up and concave down. The situations with these is that these will never have brackets involved. The only times you're really going to see brackets involved with any intervals are when you are describing domains and ranges. So in the instances of this, however, if I'm looking to see where f of x is greater than 0 or f of x is positive, that means above the x-axis, I'm looking at these parts of the graph right here. Now, at -25, which is an open dot anyway, at 0 and at 10, it actually equals 0, so I'm not including those. It's not positive there. So those endpoints are not included, but it looks like between -25 and 0, and then from 10 to 17 is when I have f of x being positive. And so that's the interval here. Again, this union symbol is going to basically be a situation where I have two separate or more intervals, and it's the equivalent of saying or. F of x is less than 0. Well, that's occurring when it's below the x-axis, and so that's going on between 0 and 10. Again, at 0 and 10, it's actually equal to 0, so I'm not having any brackets here. That's why it's, again, interval notation with parentheses. F of x increasing. Again, as we're moving from left to right, I want to see where is the value of y moving up. That's happening here as well as here. -15, 100, and 5, -20 are actually turning points. Talk about those in example 9 momentarily. However, at those turning points, it's not increasing or decreasing. It's changing from one to the other. So these do not count, which is why, again, there are no brackets being used. And endpoints, technically, you don't really know what's happening before that. I mean, there could be a radical change in this graph, and that's why it was cut here, and that's why it was cut here. So you don't know anything about the graph beforehand. So that's why you don't include endpoints either. So it's increasing between -25 and -15, and then it's increasing again between 5 and 17. These intervals are always intervals of x, so they're more or less like segments or subsets of the domain. So anytime you're doing intervals of increase, decrease, concavity, positive or negativeness, you are doing intervals of the x or independent value. For f of x decreasing, again, as you move from left to right, you want to see a downward movement in the graph. So you're talking about right here. And that's occurring between -15 and 5. So -15 to 5 is where that's happening, and it's really happening nowhere else. Concave up and concave down. That deals with the overall shape of the graph. And you can see that you have it cupping in a downward direction here, cupping in an upward direction here. They involve an inflection point. Now, finding inflection points is something you often will be left to the question, or less giving you a point that you have to kind of just accept and look at. So that's where it seems to be changing over. There's ways of finding them, but that goes into calculus, which is this course is even really not even preparing you for. So, but the inflection point is where you have a change in concavity. And so concave up would be an instance where you have this here. The inflection point is where that concavity changes. So from here and beyond, it's concave up. So between -5 and 17 is where it's concave up. And of course, before that point is where it's concave down. So from -25 to -5 is where it's concave down. Now going into local and absolute extreme values, local maximum, local minimum, absolute maximum, and absolute minimum. Now, from textbook to textbook, this can vary a little bit. In your textbook, the local maximum, local minimum are turning points only. In other textbooks, I've seen them refer to endpoints as being local maximums and local minimums. more so in pre-calculus and calculus textbooks, but your textbook basically leaves the local maximums and local minimums as the turning points only. So turning points, basically you're looking for a local maximum, you're looking for when it's increasing, and then after that point it's decreasing. So this is a local maximum because you're increasing to that point and decreasing afterwards. So that's a local maximum, and you're at negative 15, 100 for that point. The local minimum is when you're decreasing and then you're turning around at that point to go to increasing. So 5, negative 20 is a local minimum. So 5, negative 20 is that local minimum. Now, these turning points are not necessarily the absolute maximums or minimums, although they could be. For these, the absolute maximum is that you're looking for the highest point of the graph for the domain. Now, some domains, it may not have one, because if it goes on forever and keeps moving up forever, it's not going to have an absolute maximum, but it might have a local maximum. But for this one here, since it is a finite graph, you can see that the highest point is at 17,133, and so that is the absolute maximum for this graph. The absolute minimum would be the lowest point of the graph. Now, an endpoint could possibly count, but this one doesn't count, so it would be kind of hard to distinguish that as a local or absolute minimum, although minimums, they don't actually have to reach that. It is a limit value, so you could say that this would be a minimum if you wanted to, but that's not even the lowest point. The lowest point here, again, is at 5, negative 20. So 5, negative 20 would be the absolute minimum as well in this problem. But that is the end of this problem as well as this video. If you have any additional questions, please make sure to bring them up in class.